is less than 1. So in other words, before 1, the gradient is greater than 0. So the graph is going uphill. And again, it is going uphill, and the gradient is positive after 5. So far, we know the graph must look like that, and like that. That is the information that is given to us over here. So it just gives us, let me just, over there, that just gives us a little bit of a visual of what we are dealing with. Right, so what I'm going to do is I'm just going to make a rough little sketch on the side for myself so far, just to remind me of what's going on. So I'm going to say, right, hi, Winty.
Yeah?
How you doing?
I'm fine, and you, ma'am?
Not too bad. Winty, where are you phoning us from this morning?
I'm at Mpumalanga.
From Mpumalanga. And where did you find this question, Winty?
Yeah, it's for trial examination for Limpopo.
Oh, all right. Okay, it's a lovely question. Okay, so, Winty, the question says, f dash x is less than 0 when x is greater than 1 and less than 5. So basically what it means, I don't know where to draw it on the x-axis or anything now. It means that between 1 and 5 on the x-axis, my graph is going downhill. Does that make sense to you?
Okay.
Okay. F dash x is gradient. Gradient is slope. So a negative gradient means downhill. A positive gradient means uphill. So the first bit of information tells me that the graph is going downhill between 1 and 5. Are you happy with that?
Okay.
Okay. Then it says f dash x, the gradient, is positive less than 1. So that means my graph is going uphill for values smaller than 1 over there. So that makes sense. And it tells me also that the graph is going uphill for values bigger than 5. And that is how I figured out that up to this point, that is what my graph looks like. Okay?
Okay.
Now I need to interpret the rest. Now I need to interpret the rest of the information. Now it tells me f dash of 5 is 0 and f dash of 1 is 0. Now that means that the graph has turning points at 1 and 5, because the places where the gradients are 0 will be the places where we've got the turning point.
So which means...
which is at 1, x is 1, I don't know what the y value is, and x is 5. Those are the places where I've got the turning points.
Okay.
Okay, because if you think, Winty, of how you calculate the stationary points or turning points of a graph, what do? You get the derivative, you put it equal to 0, and you solve for x, right? So now they've just told us that the derivative is 0 at these particular x values, 5 and 1. Okay?
Okay, ma'am. So how do you know that x as a turning point, that 1 is a maximum value?
Because, Winty, from the information that they gave me here, in the first thing, they told me the graph was going downhill from 1 to 5. Uphill up to 5, uphill up to 1, and uphill again from 5. So that is how I knew that the first turning point was a maximum turning point.
Okay.
Okay. Now we need to interpret the rest of the information. We won't be able to draw a perfectly accurate graph, but we must at least show the people that we can interpret all of the information. If they say f of 0 is minus 6, what is that f of 0?
F at 0 is equal to minus, which means it's my Y-intercept.
Absolutely. So the graph has a Y-intercept at negative 6. So I'm just going to draw an x-axis, and I'm going to say, let's just see. It's hard because we don't know. Let me draw the graph just slightly bigger. So far, I know that that's 1, and this is 5. Remember, those are x values, and that the graph cuts the y-axis If I make that the y-axis at -6. Okay. Winty, I just need you to put the volume down on your TV because I'm getting quite a lot of feedback, quite a bit of noise in the background. So put your volume down on the TV and listen to me over the telephone.
Okay.
Okay. Okay, so are you happy with, now we've got the y-intercept. Now, also, we are also told the following, that f of 3 is equal to 0. Now, what does that mean?
F of 3 is equal, which means my x minus 3 is a factor.
X minus 3 is a factor, or I've got an x-intercept, right?
Yeah.
So, look, you'll just put an x-intercept there, 3. Oh, wait a minute. I can't actually put the x-intercept there. That's not going to make any sense because then it's after 5. So that's why you have to keep on reinventing your graph. So let's just see. I'm going to need a graph that turns at 1, turns at 5, like that. Okay. So there's my -6. There's my 1. And there's my x-intercept 3. No, it's actually 3. If x minus 3 is a factor, then x is equal to 3. Okay?
Yeah.
Okay. And that's all the information I have so far. We can't give the y values at the turning points. The final piece of information that we were given was f dash at 3 is equal to 0. So I presume that they're referring to the stationary point because that's exactly in between the two turning points. So that would be where the graph changes from concave to convex. That's all I can imagine for that. So, Winty, this is the sketch that you will give with, based on the information, name your x and your y axis, and that's pretty much it.
Okay.
Okay, so it doesn't have to be a perfect graph. You can't actually do a perfect graph based on the information that they gave us because there just isn't enough information. Okay?
Okay.
Okay, now, Winty, I've got another graph question prepared, a calculus graph question prepared here. Do you want me to do the one that I've got with you just to make sure that you're okay?
Okay.
Okay, so let's try and do that. Okay, so the question that I've got on the screen here from the KZN paper says to us, f of x is equal to x plus 1. There's a bit of noise in the background, Winty. We're going to have to watch that, otherwise nobody's going to be able to hear. X plus 1, x minus 1, and x minus 3. So what they've done in this question is they've given us the trinomial factorized. Okay. So they say, first off, calculate the y-intercept of f. Now, how would you go about calculating the y-intercept of f given this information?
Okay, firstly, I'll multiply the second bracket and the third one.
Okay, you don't have to do it. It's only for 1 mark. What do I always do when I calculate the y-intercept? I make x equal to?
X goes to 0, yeah.
So you can actually do it straight from here. 0, 0, 0. Do you see that? And then 1 times -1 is -1, and -1 times -3 is 3. So the y-intercept...
So intercept is 3.
Yeah, 0 and 3. I'm not saying that we don't need to multiply that out. We probably will later on, but not at the moment, and certainly not for that 1 mark. So let's see what the next question is. The next question asks us to write down the x-intercepts of f. And what are the x-intercepts of f?
X-intercept is -1.
Correct.
And 1.
Yes.
And 5.
And 3.
Yeah.
Okay, great. So far so good. It looks like you find it a lot easier if they just ask you to draw the graph. You don't like this other stories. Okay, now, Winty, you said just now that we need to multiply out the brackets, and we've now actually come to the point where we're going to have to, because in question 10.3, they ask us to determine the turning points of f. Okay. So what is our method for turning points? We have to get the derivative. We've got
to...
Yes?
Yeah, we have to find the derivative after so that we can factorize and find our x value.
Okay, yes.
After we must do the values that we've got to the original form to get our y value.
Okay, so for the derivative, for the turning points, you get the derivative, which describes the gradient at any given point, and you put it equal to 0. That is why in the previous question, where they said f dash 3 equals to 0, it meant that there was a turning point at 3. Okay, but now you and I need to multiply out these brackets.
Yeah.
I'm going to start with the first two, because I can see that that's going to give me x squared minus 1. Why is it x squared minus 1? Because this is like a difference of 2 squares that's been factorized. Are you happy with that?
Oh, I'm happy.
Okay. So now we need to multiply x minus 3.
So it's going to be x cubed.
X cubed, nice.
And minus x.
Minus x, right.
Minus 3x squared.
Minus 3x squared, yes.
Plus 4.
Plus 3.
Yeah, plus 3. Yeah.
Okay.
Sorry.
And no, you don't have to apologize to me. Winty, and that's now, that's a nice way to check whether our y-intercept initially was correct. So let me just write this nicely. Multiplied out, f of x is x cubed minus 3x squared minus x plus 3. Okay, Winty. Now you said the next thing we need to do is get the derivative. So do you want to tell me what the derivative is going to be?
The derivative will be 3x squared.
Nice.
Minus 6x.
Yes.
Minus 1.
Minus 1. And I'm going to put that equal to 0 immediately.
Yeah.
Okay. So you're happy with that?
I'm happy.
All right. Now, we've put it equal to 0. But this is a little bit, slightest bit problematic. This is not going to factorize easily. Okay. So let's just talk through what are we going to do next. I'm going to, what am I going to do? How am I going to solve?
To find a factor.
Okay, but I've already seen that there aren't any factors here. So what else can I do?
You can...
I've been doing a lot of that this morning. You can use the quadratic formula, right?
Yeah.
Okay. All right. So the next thing that you will do is use the quadratic formula, right, to get the 2x values. Then, as you said earlier on, you're going to substitute back to get the y values. And then you've really got all of the information that you need, and you can sketch the graph. Okay?
Yeah.
Okay, Winty, I just wanted to take you through the first couple of steps of sketching a graph, just to make sure that you know your steps. You do. So what you need to do now is practice questions where they ask you things a little bit backwards. And remember things like, if I say f dash 3 is equal to 0, it means there's a turning point at 3. If I say f of 4 is equal to 0, it means that 4 is an x-intercept. If I say f of 0 is equal to 8, it means that 8 is the y-intercept, and so on.
No.
Okay, Winty, it's been a real pleasure talking to you. Good luck with your preparation for the finals. They're just around the corner, and we wish you every success.
Thank you, ma'am.
Thank you so much, Winty. Guys, we're going to take a short break. Right after the break, we will be back with our next question. Don't go away.